For this part of the leveling up exercise, please go to the Module 2 directory and you'll see that there's a file called height weight HTWT 12-15. This is an enhanced version of the data that's being used in the book. So download this to your machine or wherever you will use it from and then load it into JMP. Here you can see the file once I've loaded it into JMP and brought it to the screen. We have the same fields of gender, we have height and weight, and age. We also have two more fields, age continuous and source. If you scroll down in the file, you'll see that there's a second set of data here coming from Clark and Taylor 1967. That data set had continuous values for age. We've rounded them off here to make them compatible. Also notice that gender here is male and female rather than M and F. So in order to make this compatible, we'll have to do a little bit of recoding. So stop for a moment and see if you can do the recode by yourself before you continue with the video and see how I do it. Here's how to do the recode. I'm going to put my cursor in gender. I'm going to right click. I'm going to say recode. Then I'm going to see the values that I don't want, female and male. I'm going to just wipe those out and replace them with the values that I do want. And then I will say up here that I will recode in place, so that gives me the same column. And then I'll click on recode. Okay, so that gives me my entire column of data that is going to be compatible. Let's follow along with the book a little bit, which means that we're going to have to limit the data that we're looking at to the gender and height for 12-year-olds from the JSS source. So to do that, we'll simply say rows, we'll say row selection, and then we'll say select where. We'll say select where the source equals to JSS, and then we need to add an additional option. We're going to add that condition first. Then we're going to say if all conditions are met. The second condition is that age, which actually you can see here that I've changed already to be a nominal variable. And I'm going to say age equals 12, and I'll add that condition, and then I'll click on OK. Now what that has done is it's highlighted the 63 items that actually meet the criteria that we want. The problem is that we actually want to exclude all the other ones. So I'm going to go back to row, and I'm going to say row selection, and I'm going to say invert row selection, and that'll give me everything else. And then I can say rows, and I can say hide and exclude. So I've now excluded 276 rows, and I've included just the rows for 12-year-olds from the JSS source. If we want to see that that is correct, we can go Analyze Distribution. I can put in gender, height, age, and source, all the fields that we're looking at. Click on OK, and you'll see that we have 63 values. The sources we have is only JSS, the ages we have is only 12, and this is showing our histogram similar to what you see in the book at this point. Figure 8.3 in the book shows a display that looks like this. We said Analyze, and we said Fit Y by X. We put gender in X, and then we put height in Y, and we clicked on OK. And here's our scatter plot with dots that sort of represent each point. If you have a large number of points, these dots don't really represent each point because they can't really fit all of them on. Also, the reason why they are gray is because some rows are highlighted over here. So if we really want to make this so that it does not show gray rows, we can go back to the main data table and say row and say clear row state. However, that would take off our excluded and hidden rows, which we do not really want to do, so we will simply live with the fact that they're gray for now. The other thing that he did was he showed how you could label these values here that seem like they might be outliers. Are they actually outliers though? So there are two ways we can find out. If we click on the right triangle here and then we say display options, notice all the different things we can see. Let's get box plots. and then we can see, well, okay, it does look, we might have a few outliers, but convince yourself as to why it is that we should not actually exclude those outliers. Okay, the next thing I want to do is see the means and standard deviation, so I'll just get that by clicking on the red triangle and pulling that down. We can see that for males, the mean is 58.8 inches, and for females, 59.5. The question is that a statistically significant difference? So up here, if I go again and say display options and I get my means diamonds, one way to tell is whether or not they overlap. So if they overlap, that's pretty good evidence that we're not going to find a statistically significant difference. Another way to see is whether or not the two confidence intervals overlap. So we've got 58.3 to 60.6 and 57.7 to 59.9. 59.9 is actually bigger than 58.3, and so we have an overlap. And remember that this confidence interval says that out of 100 times when we take a sample and we calculate the mean, 95% of the time, the sample we get will give us a mean that's in between these two values. Now we are ready to do the actual statistical test, so we'll come up here and click on the red triangle, and we'll say t-test, and let's look at the output. So as the book points out nicely, the difference between males and females is minus 0.62. So remember, this is male minus female, so that means that females at this age are actually taller than males. So make sure that you look here in order to understand what the signs are that you're seeing here. Also, when you see these three p-values down here, they are relative to the way the test is being performed. Male minus female up here. Jump decides on this order because of the alphabetical order of the variables. So we have a probability that the t, or that is to say the critical value that we need to look up in order to see if this is statistically significant, is 0.41. This is our p-value. It's greater than 0.05, and so we have to fail to reject the null hypothesis. Notice that sometimes JMP gives you this nice little output when you put your cursor over here. It says not significant at all. Let's see if we get it for this one. Okay, there we go. Not significant at all could easily be this large by happenstance. More data might help. P-values are the probability of getting an even more extreme statistic given the true value being tested is at the hypothesized value, usually at 0. That is to say, we would expect there to be no difference between males and females. So we can, at this point, say that we have failed to detect any difference between males and females, failed to reject the null hypothesis. A source of confusion is what to do about equal or unequal variances, what assumptions to make. So what the book is saying is that it's best simply to assume unequal variances and use the t-test, and this is the t-test that comes right here, which we've already asked for. If you want the pooled t-test, this would be used for very small sample sizes or where you know that the variances are equal. It's a more sensitive test. So if you click on here, you're going to see that it opens up. I already actually closed these earlier, so they stay closed, and then you'll see it's labeled the pooled t-test. I think we'll find in this case that there's very little difference between the numbers that were calculated here, and that's often the case. If there are big differences, then it is something to look into, but I would say for this class, you can simply not use the pooled t-test, close that out, and go ahead and use the regular t-test that comes from the red triangle right up here. At this point, the book chapter has a section called Analysis of Variance in the All-Purpose F-Test. If you had unlimited time and interest, this would be a very good section to read and understand in full. We will be talking about things like residuals, and we will note some characteristics of the F-test, but in general, this is not something that we can spend much time on. We'll go down a little bit further in the book chapter, and we get to another section called How Many Observations Are Needed. This is actually a rather useful little section to have here because it shows you how to use JMP's calculator for seeing what the sample size needs to be in order to get a certain power. So remember that power refers to the chances of making a type 2 error. The power is the probability that we failed to reject the null hypothesis when we should have. That's like saying I should have diagnosed that you had a disease, but I didn't. Whereas the type 1 error, which we look at using the p-value, is where what's the probability that when I did diagnose you with the disease, that in reality you did not have the disease. So that's like calling you guilty when you're really innocent, and the type 2 error is calling you innocent when you're really guilty. I'm going back to JMP now, and I will show you using this sample size calculator. So here we are at our data table. We're going to say design of experiments. We're going to go to design diagnostics, and then go down to sample size and power. And then we're going to choose the calculator for 2 sample means. At this point, we have to know what the standard deviation is approximately of the data that we are looking at. And how can we find out what that standard deviation is? I'll go back to Analyze, say Distribution, put in height, click OK, and what's my standard deviation? About 3. That's where the book gets the value 3. Okay, so back to my sample size calculator. I'm going to put in 3 for the standard deviation. And I'm going to say that a difference that makes a difference to me is, let's say, 0.5. So half an inch. What would it take to detect a half an inch? How many actual records do we need in order to get a power, that is to say, to give us a good assurance that we are going to not make a type 2 error? I'll click on Continue, and it shows me this very nice curve here, and I'm going to go to my magic menu. This time I'm going to get the crosshair menu. That allows me to move up and down a line anywhere I want to on a graph and see the 2 corresponding values. So if I want a power of 0.9, that is to say a 90% chance that I'm not making a mistake when I fail to reject the null hypothesis, then I would need 1,500 records, which is way more than we have right now. So in fact, the number of records we have, which is I think around 30 records or something, you can see that the power is 60 records. I think the power is really quite low, which means to say that there is some non-trivial possibility that we will be making a type 2 error with this data. Okay, let's skip ahead to the main point here that we want to make, and that is to say, at what point in time do males actually start to get a lot taller than females, according to this data? So I'm going to just go ahead and exit from what we've done before, and I'm going to go back to my JMP data table. And let's see, right now I have, if you recall, many rows that have been excluded. So I'm going to go to rows and say clear row states. That'll take off all of the exclusions and give me back all of the data that we have. And now I'm going to show you an extremely useful shortcut that will, again, hopefully convince you about the power of JMP. I'm going to say Analyze, I'm going to say Fit Y by X, and then I'm going to put in gender as my X factor. I'm going to put height as the response, and then I'm going to take age and I'm going to take source and put them in the by box. So what this is going to do is it's going to take every value of age in conjunction with every value of source, so all those combinations, and it's going to do this analysis up here that many times, all in one fell swoop. So here we go. Click on OK, and how many analyses have I got here? It looks like I have quite a few. I note right away that for age 21, age 18, and for age 17, we don't have enough data. So those we won't look at anymore. As a matter of fact, I'm going to show you another shortcut in a minute here. But first, let's go ahead and click on this red triangle, except before you click on it, hold down the control key. When you do that, it will apply whatever analysis you're asking for the first time to everything else that's on this report. So I'm going to hold the control key down, click the red triangle, and I'm going to say t-test. And right there, I'm going to be seeing what the results are for every single one of these combinations. The other thing that I can do is I can hold this red triangle, hold the control key down, and I can ask for the normal quantile plot, the actual by quantile. Now the book talks about this plot, and the point is that the closer all the dots are to the line, the more normally the data is distributed. I don't have really large sample sizes in this data set, so it's not a bad idea to check to see if there are large deviations from normality. In this particular first one, you can see that both male and female are reasonably close to the line, although there are some deviations, but I wouldn't say that they're so extreme to worry about it. The same thing for this one here. Now looking through all of these, this one might be a little bit more worrisome with that big bulge there for the females. Move down a little bit more. That one looks good. That one looks pretty good. That one looks pretty good. So I would say for the purposes of our class, unless you see really big deviations here, you can assume that normality is not going to be a problem. This is the quick and dirty way of checking the normality right in the middle of doing an analysis. So the next thing I want to look at is all of these t-tests, but let's first hold down the control key again, and I'm going to go up to this red triangle, or sorry, the gray triangle here, and I'm going to click on it, and it's going to close everything. Now why would I want to do that? Well, the reason is because now I can open them up one by one, and I can take a good look at each one and kind of absorb what it's telling me. So let's look at, first of all, at the 12-year-olds from the JSS source, and you'll see this is the same analysis that we were just looking at, and we see that our p-value is not significant, and so this difference that we're seeing here is not something that we can believe in. Essentially what we're saying is males and females cannot be distinguished in height at age 12. How about the Clark and Taylor source? Let's close that one out. Open up Clark and Taylor, and we see once again here it's not exactly the same size p-value, but that doesn't matter. It's still above 0.05, and so we're not seeing a significant difference here. So once again, we have no reason to believe that this difference of saying that females are 0.76 inches higher is actually true. We failed to reject the null hypothesis that there is a difference. How about at age 15? So this is the other one that the book is showing you. So age 15, I'm going to open up the JSS source, and here the points are showing us a clear difference. If I want to go ahead and get my display options and show the means diamonds, you'll see that they do not appear to overlap. And then if I go down here and look at my p-value, I can see, yes indeed, this is telling me to reject the null hypothesis, and it's telling me that I can believe this difference. The difference is 3.7. By now, males have gained almost 4 inches over females, according to this data. What about the Clark and Taylor source? I'll close that one out, open up the Clark and Taylor 415, and this looks like it might not be as clear. Let's see what our means triangles tell us. Red triangle, display options, means diamonds. Well, they don't look like they're overlapping. And indeed, we have a significant p-value here once again. And so here the difference is a little bit less, but we still can say that males are taller than females at this point in time, given this sample. So I'm not going to open up the rest of these, but what I want you to do and answer questions on the quiz is I want you to open them up and properly interpret them and be able to be ready to answer a question about when males actually start to really grow and overtake females.